Okay, in today's video, we're going to actually be revisiting a topic that we discussed back in geometry. This topic is called the Law of Sines. And the Law of Sines is actually used when we know that sine, cosine, and tangent, we use SOHCAHTOA when we're talking about right triangles. However, Law of Sines and then eventually in the next video, Law of Cosines is used when we're talking about acute or obtuse triangles. So we're no longer dealing with right triangles. Now we're dealing with the other types. So we're going to use these two new laws. And again, it's a way of finding missing angles and missing sides of these triangles. And here's what the actual law of sine says. It says that the ratio of the sine of an angle to the side across from it, which, by the way, notice that if you're going to be talking about angle A here, that side A is the side across from that. If you're talking about angle C, that side C is the side across from that. And so you can see the same thing with B, that the ratio of the sine of that angle A over the side across from it will always equal the ratio of the sine of angle B to B. And those will also be equal to the ratio of the sine of angle C to side C. So the sine of A, the sine of this angle over this side will always equal the sine of this angle over this side. And eventually, in the third part, it'll also equal the sine of this angle over this side. So the law of sines can be used to find side and angle measures when we're given two angles, and they classify it in the angle side or angle side angle. You don't have to know that. It says or the two side lengths and an angle in this situation. You can use it. However, you don't have to know those, because what I do is I just say use it if you can. And then if you can't use the law of sines, then we're going to be talking about the law of cosines. Okay, first problem, let's actually try these now. Find each missing measure, round all answers to the nearest tenth. So the first thing is we've got to set this equation up, this proportion, you can say. We know, and look, there's no A, B's, and C's. It doesn't really matter, because the actual law of sines states that the sine of an angle over the side across from it, so it'd be the sine of 34 over 10, will equal the sine of an angle over the side across from it. So you have a very simple proportion to solve. So in order to solve this proportion, now if this were an ACT test, again, we don't have to use calculators, so how would they leave this answer? Well, to solve a proportion, we multiply the two diagonals. So we got 10 and sine of 52 are diagonals of each other, and then we divide by the other side, or the other value. So that's how you're going to type that into your calculator. To find the value of x, we're going to do 10 times sine of 52, and we're going to divide that by the sine of 34. And when you do that, you should get about 14.1. So that would be your missing side length. Next problem, let me zoom in just a little bit here. There we go. So again, the sine of an angle over the side across from it. So here's my angle across from 21 degrees would be 7, will equal the sine of 119 over the side across from it. To type into our calculators, we're going to do 7 times the sine of 119. So 7 times the sine of 119, you can type that in. And then we're going to divide that by the sine of 21. And you should get about 17.1. Next problem. We have the sine. Now here's the side length that we're given. So we're going to have to do the sine of 64. So this one's a little bit tougher. The sine of 64 over 32 will equal, we're looking for x here. However, we don't have this missing angle here. But we do, because we can remember from geometry that the three angles inside of a triangle have to add up to 180. So if we have 64 and 45, that's 109. That leaves you with 71 degrees. So we're going to do the sine of 71 degrees divided by x. Type this in as 32 times the sine of 71. Divide that by the sine of 64, and you should get about 33.7 would be your missing side length. Number 4. Same thing. You don't have the angle across from 19 here. So we're going to add 110 and 41. That's 151. So that leaves me with a 29-degree angle. So the sine of 29 over the side across from it will equal the sine of, we're going to use 110 since we're looking for x. The way you type that again into your calculator is the two values that are diagonal. We're going to multiply those. This is solving basic proportions. So we're going to do 19 times the sine of 110. We're going to divide that by the sine of 29, and we're going to get about 36.8. Okay, next up. Number 5 and 6 says Kevin, Adam, and Dan are passing a hockey puck. How far is Kevin from Adam? So we've got our diagram over here, and we want to know how far Kevin is from Adam, so that would be this value. So the way that we set that up, well, first off, we know that 86, whoops, undo. The sine of 86 over 25 will equal, we need this angle, so we do 71 and 86 is 157. So that leaves me with a 23-degree angle. And something else to remind you about geometry is if you have a small angle, you'll be across from a small side. The biggest angle, notice here the biggest angle out of all these should be across from the biggest side. So as you're working through this, I know that this value here has to be less than 25, and I think it's going to be a good bit less than 25 because 86 is a much larger angle than 23. So a smaller angle will always be across from smaller sides inside of that triangle. So the sine of 86 over 25 equals the sine of 23 over this value. The way we type that in again is 25 times the sine of 23. And you'll divide that answer by the sine of 86, and you should get about 9.8 feet. And you can see that he is a good bit closer. The second part says, how far is Dan from Kevin? So now I'm gonna use maybe y for this. And we want to know how far Dan is from Kevin. So we can actually start out the problem the exact same way because I know that the 86 degrees is across from 25. So I know the sine of 86 over 25 should equal, across from this y value that we're looking for now, is the 71-degree angle. So is equal to the sine of 71 over y. And you type it in the same way. 25 times the sine of 71. Take that answer, divide by the sine of 86, and you get about 23.7 feet. About. And again, the squiggly equals there means about. Okay, now let's work these problems backwards. Finding angles. Now this is a little bit different, so we got to be careful. The sine function, it says watch out. When finding angles, it's possible to have one solution, just like on the last problems, two solutions, or no solution. And this is called the ambiguous case when you have these different solutions. And here's why this could be true. If you remember a sine curve, sine of 0, 0, sine curve looks something like this. It continues on forever in both directions. The sine function always has a range. It never gets above 1, and it never got below -1. So it has a range somewhere between -1 and +1. If the sine function is positive, now let's go to this now. All students take calculus. In the first quadrant, everything's positive. In the second quadrant, sine is positive. In the third quadrant, tangent's positive. And in the fourth quadrant, cosine is positive. So if sine is positive, it could be either in quadrant 1 or it could be in quadrant 2. So therefore, we've got to be careful because what if I tell you, let me come down here and just use this to draw right now. What if I tell you that the sine of some angle is equal to 1/2. And you say, oh, I know what that is. It's right here. That's the sine of a 30-degree angle. But you've got to be careful because sine is also positive in the second quadrant. And a reminder that on the unit circle, a sine value is a y value. So therefore, you've got another angle in the second quadrant that's going to have that exact same y value on your unit circle. It's going to have the exact same reference angle. And to actually find it, okay, if 180 is all the way over to here, we'll take that reference angle away, and that would be a 150-degree angle. So the sine of 30 and the sine of 150 is the exact same thing. The sine of 20, okay, let's look at that. The sine of 20 and the sine of this angle over here that has a reference angle of 20 is the exact same thing. So if this is a 20, then this would be 20 as well. So the actual angle would be 180 minus 20, which is 160. So you do have a shortcut here. That notice this was 30 and 150 had the same sign, 20 and 160 has the same sign, and you can check me on this. 5 degrees and 175 degrees have the same sign. 40 degrees and 140 degrees has the same sign values. These angle pairs, if you haven't noticed yet, are supplementary. So that's one good thing. That's a shortcut that we can use. So to find the other possible angle, subtract from 180 degrees. That's going to give you the second angle, the second possible answer there. The sum of the angle measures in a triangle is always 180. That might be something else that we have to use for this. No triangle can have two obtuse angles. So remember that also as we're working through these problems. So let's work through one of these and show you why these are slightly different. Problem number 1 says the measure of angle A is 50 degrees. AB is 4, BC is 9. I've got to draw a picture just so I can keep track of my thoughts. So I've got some triangle that has an A, a B, and a C. It doesn't have to be drawn exact, but I know that A is 50 degrees. AB would be this side, has a length of 4. BC has a length of 9. And we're asked to find this angle, angle C. We set it up the exact same way. The sine of 50 over 9 will equal the sine of x. I don't know the value of that angle over 4. Solve it the exact same way. We're going to multiply the sine of 50 times 4. Then we're going to divide by 9, but there's an issue here. And here's how you can think of it. The reason we're actually multiplying by 4, when you're solving a proportion, here's what you're doing. When you multiply by 4, well, this is division by 4. When I multiply by 4, it moves it over here through multiplication. So look what I've got now. When you do this work, you do the 4 times the sine of 50 and then you divide by 9. That doesn't tell you the value of x. That tells you the value of the sine of x. So what you're going to have now, the sine of x, you're going to have an extra step when you're looking for an angle. The sine of x equals 4 times the sine of 50 divided by 9. And that's going to equal somewhere around 0.3405, but don't clear your calculator screen. Leave that on there because here's going to be the next step. To actually find this angle measure, to find out what x is, this is going to be review. We've done this already. We've got to take sine and move it to the other side. To move a sine to the other side, we do inverse sine. So we're going to type into our calculator the inverse sine of 0.3405, and that's going to tell us what angle x, the angle that we're looking for. So x is going to be about 19.9 degrees. But here's the problem, and let's go ahead and clear this up. Your calculator could possibly be lying to you. Because yes, I know the sine of 19.9 is that 0.3405, but you've also, if this is a 19.9 degree angle, you've got another answer. If the sine of some angle is 0.3405, this is only one of the many possible answers. You might have a second quadrant answer which has the exact same 19.9 degree reference angle. The way you find that second quadrant possible answers is you take it from 180. Take this reference angle from 180 and you get, or x could possibly be 100, and I believe that's 160.1. So there's two possible answers here. But let's look and see, are they both possible? I know that x could be 19.9, but is there any way that we can have a 160.1 degree answer? And that's the reason we put this right here, that the sum of the angle measures in a triangle is always 180. Well, if this is 50 and this is 160.1 here, that's already well over 180. We can throw that answer out. So we do only have one answer to this triangle. The next problem, start out doing the exact same thing. We're going to draw triangle ABC here. And just know that this drawing might not be extremely accurate as to how this triangle would look. I just need somewhere to label my information. I know that angle B is 37 degrees. I know that AB is 47. AC is 29. And I'm asked to find the measure of angle C. It's jumping all over the place on me here. Okay. So let me zoom in so that I can hopefully stay away from the edge of my computer screen. So let's set this up. I know that the sine of 37 degrees over 29 will equal the sine of x over 47. To solve this again, we're going to move the 47 over by doing 47 times sine of 37 divided by 29, or you can just do this. Just put the 47 right there. And that's going to tell us what the sine of x is equal to. However, once you find that, just keep in mind that that doesn't tell you the value of x, it tells you the value of sine of x, so we will have one more step. And when I type that in, I get the sine of x is equal to about 0.9754. And again, you have one more step to get rid of sine. We do have to do inverse sine. So we're going to do the inverse sine of 0.794. And I get that x is about 77.3 degrees. But again, keep in mind, there is a second answer. 77.3 is here. Well, you've got another angle here that's going to have the exact same sine value. It's going to have the same reference angle. The way that you find that second angle, again, is just simply subtracting that from 180. And I get about 102.7 for my second angle. And you ask yourself, are they both possibilities? Could x be 77.3? When I add that to 37, yeah, that leaves me some room over here. But what about 102.7? If I take 102.7, add it to 37, will that give me enough angle left to where I'm going to have a third angle? And the answer is yes. I actually have two different answers on this problem. So x could be either one of those answers. And if you ever want to see a video of why this could be true, you can look up the hinge theorem, and it'll show you that that you could actually attach this and swing it in, and that's the reason why there's two possible answers. You might have an acute or an obtuse triangle here, and you could see why this is a true statement. Number 9. You have another triangle ABC, not drawn to scale. C is 75 degrees. AB is 28. AC is 19. So we're looking for angle B. And anytime you're looking for an angle, just go ahead and be ready. You're going to use inverse sine. That's what inverse sine, inverse cosine, and inverse tangent are used for, is to find angle measures. So I have the sine of 75 degrees over the side across from it will equal the sine of my x value over the side across from it. To move the 19 over, I will multiply, and I'll get the sine of x will equal about 0.6554. To actually find out the value of x, I'm going to do the inverse sine to move sine over of 0.6554. And that gives me that x is about 40.9 degrees, or take that from 180, and my other angle would be a 139.1 degrees. Again, the next question is, are they both possible answers? Well, if x is 139.1, if you add that to 75, you're well over 180 already. However, 40.9 is going to be a legal answer. Next one. And I have a funny feeling we're fixing to run into a no solution one. So you have the measure, you have A, B, and C. Angle A is 114 degrees. AB is 34, and I'm going to show you how to spot a no solution sometimes before you even work these things out. And this is definitely a no solution. And if you'll use some of the information that I taught you in geometry, if you'll look at this, 114 is across from 12. X is across from 34. A bigger angle is always across from a bigger side. So that means that since 114 is across from 12, and this angle here is across from 34, that obviously angle X has to be a bigger angle. Well, how can you have an angle in a triangle bigger than 114? Because they only add up to 180. So therefore, I can already throw this problem out before I even work it. There's no way possible that X can be bigger than 114. You would have two obtuse angles in the same triangle. That's not possible, but I'll show you. The sine of 114 over 12, and we'll run into another mistake here in just a second that can't be, equals the sine of x over 34. Move the 34 over by multiplying, solve the proportion, and I get the sine of x is equal to 2.5884. Okay, let me remind you of something. If you're talking about sine is always between -1 and +1. Sine is never above 1. So a sine value of 2.5884 is not even possible. When you do inverse sine of this, it's going to give you an error message. There is no solution to this triangle. There is no way possible that this triangle could work. Okay, I believe we got two more problems. You draw another triangle, ABC. I have that the angle B is 47 degrees, AB is 33, AC is 26, and we're asked to find the measure of angle A. Now, I've already got some issues here. I see that I know that the sine of 47 over 26 shows me I can use a law of sines. However, I'm missing something. I'm missing this side across from x. So here's going to be my steps. I'm going to call this angle y, and I'm actually going to find angle y first, because I know that once I find angle y, the three angles have to add up to 180, then I would know what x is. So since I'm given this side 33 over here, I'm going to have to do the sine of y over 33. Move the 33 over by multiplying. So I have the sine of y would have to equal 33 times sine of 47 divided by 26, which is about 0.9283. To get rid of sine, we're going to do the inverse sine of 0.9283. And that's going to give me that y is somewhere around 68.2 or 100, let's say that'd be 111.8. So I have two different y values. And here's the scary part, both of those are legal. You can add 111.8 to 47, and that leaves a little bit of room. So that means, okay, x, I'm going to have two different possibilities for my angle x here. And here's how we're going to do it. Angle B is 47 degrees. If I were to add 47 plus that 68.2, that gives me 115.2. So if those two would add up to 115.2, that leaves me with 64.8 degrees for this x value. There's one of my answers. Or I have another answer. If my first angle was 47, that's angle B, or my angle C here could be 111.8 degrees, which gives me a total of 158.8, which means my third angle, that would leave 21.2 degrees for my third angle. So my three angles are either 47, 68.2, and 64.8, or my three angles are 47, 111.8, and 21.2. The last problem. Let me draw my triangle, ABC. C is 73 degrees, AB is 8, BC is 17. Find the measure of angle B, and it's going to be very similar to the one that we just worked. I have the sine of 73 degrees over 8 equals. I don't have this side length here, so I can't actually find that. I can't find that angle yet that I'm looking for, so I'm going to call this anything. You can actually just leave it Y or A if you want to, and just do the sine of A over 17. That'd be perfectly fine. Move the 17 over by multiplying. We're going to do 17 times the sine of 3, 73 divided by 8, and that's going to give me the sine of A is equal to 2.0321, and that's good news because we know that the sine of A can't be 2.0321 because sine is between -1 and +1, so therefore there is no solution. Angle A has no answer, so therefore there's no way to solve this. And since we have no answer for A, there's absolutely no way that we can have an answer for B. So my final answer is there is no triangle that satisfies these conditions.